In this video, we are going to be looking at example 6 on page 220 of the Maths Handbook and Study Guide for grade 12. The question reads, tangents to the circle x squared plus y squared equals 15 are drawn from the point P16. Determine the x-coordinates of the points of intersection of the circle and tangents at Q and R correct to one decimal place. Now, the maths in this question gets a little bit tricky, but it uses the same concept if you've watched the previous videos as example 4, where we write a point in terms of x only. So they're asking us to find the x-coordinates of point R and the x-coordinate of point Q. The first thing I need to do is write point R in terms of x only. And to do that, I use the equation of the circle because we know that point R lies on the circumference of the circle. So what we're going to say is we know x squared plus y squared is equal to 15. And I'm trying to solve for y. So y squared is equal to 15 minus x squared, and therefore y is equal to plus or minus the square root of 15 minus x squared. Now just remember, Q and R are both on the positive y-axis, positive side, and therefore it can't be plus or minus, so it is just plus. And another common mistake is you cannot write this as the square root of 15 minus x. You are not allowed to square root over a plus or minus sign, so those are not equal. Don't do that. So now we can write point R as the coordinate x, and the square root of 15 minus x squared. And the reason I want to do that is because I can find the gradient of my radius using point R now. And I know because the radius is perpendicular to the tangent, I can work out the gradient of PR. And I can also work out the gradient of PR using points P and R. So that's what we're going to do. Let's start off with the gradient of OR. So my gradient of OR is equal to y2 minus y1, and the circle center has coordinates 0, 0. So we're going to go the square root of 15 minus x squared minus 0. I'm not going to write the minus 0 in, all over x minus 0. Again, I'm not going to write the minus 0 in. So now I can say, from the properties of perpendicular lines, m of PR is going to equal to minus x all over the square root of 15 minus x squared. And apologies, that should have been an x squared over there. So now I've got the gradient of PR using the fact that it is perpendicular to my radius. I'm now going to find the gradient of PR using points P and R. So y2 minus y1 over x2 minus x1. So we're going to have the square root of 15 minus x squared minus 6 all over x minus 1. Now both of these equations represent the gradients of PR, so they're in fact equal to each other. And we're now going to solve simultaneously for x. And this is where the maths gets a little bit tricky. Be careful not to make a silly mistake. So we're going to have the square root of 15 minus x squared minus 6 all over x minus 1 is equal to minus x all over the square root of 15 minus x squared. And once again, that should be an x squared there. Don't forget to leave it out. Don't forget not to leave it out. So now we're just going to simply cross multiply. This goes straight into grade 10 and 11 maths, where we're going to have the square root of 15 minus x squared into the square root of 15 minus x squared minus 6 is equal to minus x times x minus 1. So we're going to multiply this in. That's going to give us the square root of 15 minus x squared all squared. So the square roots cancel out, and we're left with 15 minus x squared minus 6 times the square root of 15 minus x squared. And on the other side, we're going to have minus x squared plus x. So now this goes down to simple surd equations from grade 11. We want to isolate the surd, so we're going to take the square root over to that side and bring everything else over to the right or the left-hand side. So we're going to end up with 15 minus x squared plus x squared is 0, so it's 15 minus x is equal to 6 times the square root of 15 minus x squared. And for surd equations now, all we do is we square both sides, now that we've got the surd isolated. And we're going to get 225, which is 15 squared. Don't forget your middle term, multiply and times by 2, so that becomes minus 30x plus x squared equals, you're squaring the entire bracket, so don't forget you have to square the 6, 36 into 15 minus x squared. Now in a question like this with big numbers, please don't be afraid to use your calculator. Okay, I'd rather you spend an extra 30 seconds getting the answer right than making a silly mistake and getting it wrong because you didn't use your calculator. So this is 225 minus 30x plus x squared equals 36 times 15, which is 540, and then minus 36x squared. And now we're going to take everything over to the left-hand side because we have a quadratic equation. So we're going to end up with 37x squared. That's my x squared plus 36x squared minus 30x. And then we've got 225 minus 540 on our calculator again is minus 315 equals to 0. So once again, this is a quadratic equation that doesn't factorize. We've dealt with this in previous videos. So we use our quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Or if you have a calculator like I do that can find the roots of an equation, we're going to plug in our coefficient of a, minus 30, minus 315 into the calculator, and that pops out a nice answer of, therefore, x equals 3,35, or x equals minus 2,54. Now be very careful. The question originally said correct to 1 decimal place. So this answer is actually 3,3. We have to round off. So that's not 3,35. It's 3,4 and minus 2,5. In the next video, we'll be looking at example 7 of the Maths Handbook and Study Guide for grade 12 on page 221.